So you're probably thinking, what the heck? Last video was so long. Well, yeah, it was. Um, I'll try to make this one a little bit shorter. Yeah. So what do we have to do now? Well, we know what derivatives are. We can now learn integrals. Now, before doing that, I should have explained something earlier, which are limits. Now, that's why this video is going to be shorter, because limits are sort of easy to understand. So if we have a graph, simple graph, and we have, let's say, the graph of 1 over x, then it's going to go like this, right? This should actually go that way. So how do we know that? Well, we know that as x approaches 0, from the right, it's going to go up to infinity. How do I know that? Again, because 1 over 0.1 equals 10. 1 over 0.01 equals 100. So if we go really close to 0, we get to infinity. Now we are not saying that 1 over 0 is infinity, because it's not. Because if we go back here, we are going to negative infinity here and positive infinity if we go from the right. So what do we have here then? We have this notation that is lim, and then x approaches, and let's say 0, and we have this notation that says from the right is plus, because we say that our right is plus and our left is minus. So the limit as x approaches 0 from the right, and this is 0 over there, this y-axis is 0, then it goes to infinity. Oops, that is supposed to be infinity. Now, limit as x approaches 0 from the left, what is that? It's going towards negative infinity. We can see it in the graph. There's more though. If we look at the graph again, we don't necessarily have to stick to 0. We can say lim as x approaches infinity. So our x value goes to infinity over there. Then what does y approach? Our y value approach. It goes really close to 0. So that means limit as x approaches infinity is 0. Now limit as x approaches negative infinity, what is it? Well, it is also equal to 0, because it gets really, really close to 0. And that's how you can actually make a lot of approximations. A lot of people use limits to make approximations. So for example, you have a graph, and it's not the straightest line. But you have a graph, and for example, it goes like this, right? What is this graph? Well, you might say it looks like sine, because it's supposed to be sine x. But my drawing does not illustrate it. So we have sine x. Well, the limit as x approaches infinity, what is it? It's always going to do this oscillation. It's always going to go up and down. It's never going to actually go to 0 or 1 or negative 1. So we say that the limit as x approaches infinity does not exist because there is no limit. It does not approach any one value. It always stays between the range of negative 1 and 1. So what do we do with this information? Well, derivatives are actually just limits. What people do is a derivative is just f at x plus some number h minus f at x over h, and that is with the limit as h approaches 0. What does this mean? Well, that means that we have a graph and we take one value here. That is f of x. F of x plus h, let's say if we say as h approaches 1, then it's going to go over here. But if we zoom in here for a second, we can see it goes like this sort of, right? We have a point here, we have a point here. Well, if we make our approximation, instead of 1, we make it 0.5, it's going to go here. And 0.3, it's going to go here. If our approximation goes to 0, then it's going to be on it. And then we can actually find the tangent. So you can actually find the derivative of a function with this method. The problem is it's so much easier to just find a derivative of a function in the other way, that this way is overkill, kind of. So how does this work? Well, if you just divide by 0, if you just put in a 0 here, it's going to be division by 0. It's just going to be f of x over 0. You don't want that. So what you want is to have f of x plus some tiny number plus f of x minus f of x minus f of x over h, which is some tiny number. And then if you actually rearrange these things, this function, you will find that h and h will cancel out. Not yet, because they are inside, this is inside the function. You can't just cancel it out. But after a while, and I will not teach this because I don't feel it's necessary. It's just to teach the concept of a limit. After a while, you can cancel off these two h's by sometimes multiplying by the reciprocal, which is just, let's say, x plus 1. The reciprocal would be, so if y equals x plus 1, then y bar, which I call the reciprocal, is x minus 1. So that way, if we multiply x plus 1 times x minus 1, we get x squared minus 1. We don't have to worry about the number in the middle, which would be 2x or negative 2x. We don't have to worry about that. So that's for solving. And in calculus, this is the first thing you learn because it leads to derivatives, but I feel it wasn't really worth teaching it since it's not really used after since it's not really used that much later on, since limits are used, but this way to find derivatives is not, and it's so not used that so unused that I don't even remember the name for it. So yeah, this was limits, and next time I think I will be ready to do integrals or summations. I'll have to see which one. So yeah, thanks for watching.